and our capsule, see what's happening here. Okay. Now, what happens if we don't hit something when we do our line anything? But we have this 97 off the break hit result. And if I have my numpad on, that would probably help. There we go. And how far do we want to shoot that down? We'll just throw out a number here. We'll say something like 100 units, something like that. So that's going to shoot a line down from the pelvis 100 units. Okay. Okay. And then what we'll do is determine if we hit something. So I'm going to hold B and left click to create a branch. And we'll connect this up and connect that up. Okay. And we can take our out hit and we can break that apart. So we can break the hit result, get all kinds of information. The one we're really worried about here is just the location. Okay. Now we don't want to use just the location by itself. If we look at our mesh and we go to the details panel in the viewport here really quickly, over in the transform we have this offset of 97 centimeters. We actually have another one here, which I could just set to 0. It's not going to bother anything. But we have this 97 centimeter offset here. If we were to set this to 0, you can see our character kind of pops up into the air. So we're going to need to account for this when we go to use it a little bit later. So I'm going to set that back to 97. So in our calculate mesh, what we're going to do is we're going to take the location off the break hit result, the plus sign, so we can do a vector plus vector. And along the Z, we're going to add that 97 centimeters as an offset. And this is going to be, if we actually hit something, we're getting the location that we hit, adding 97 centimeters to it. Now we're going to promote this to a variable, so I can right click on this, variable, call this capsule. Nothing in space. What do we want to do in those instances? Well, we're just going to set it to the location of our pelvis bone plus that 97 centimeter offset. So what we can do is we can come back here, I can grab these two nodes here, just copy and paste those somewhere down here. Okay, and we drag off of this and hit a plus sign, vector plus vector, again accounting for that 97 centimeter offset there. That's also going to be our capsule location. So I can drag this in and just drag it right on top to set it. Okay. So now we have set up what happens when we are close to the ground and when we're in the air. And now the next thing that we're going to do is actually interpolate from the position at which we started ragdoll, moving the capsule to the location of our
Hey guys, how's it going? I hope all of you are going to happen soon after
drag this in and just drag it right on top to set it. Only worried about the Z, okay? We're this phone, the mesh, set its orient. Okay. We also want to kind of following this in our third-person movement here. We're going to turn off the movement. So remember,
It's a fraud game where you.
So let's go ahead and bring in our mesh. And we're going to say get socket rotation of the pelvis. So, and we're going to use the right vector here. We're going to say get right vector pelvis. And we're going to compare this against the Z value of 1.0 with dot product. Value, the return value here is greater than 0. It means we're facing up. It's not, we're facing down. That's how we can determine if we're facing up or down. I did something similar to this in the blueprint on our vehicle. So our vehicle, when our vehicle flipped over, we determine when it's actually flipped over. We did something similar to this. We'll use that equal 0. Just plug that in. So this will tell us if we're facing up or facing down. And come back to the event graph here, and because that is a pure function, we can just take in that calculate facing direction, drag it directly into the graph, and it's just going to give us that value. Okay. Now we're going to store this as a variable once we find out if we're facing up or down. So I'm going to right click on this and promote this to a variable, which I'll also call is facing up. So, okay. All right, the next thing that we're going to need to do is determine the orientation of our mesh. So when we go into Ragdoll, our character goes into Ragdoll, when we pop up, we're going to want to know which way he's facing so that he pops up in the same direction. Otherwise, what might happen is he might pop up and be facing the wrong way. Something that works here, it just depends which way the camera is as well. So we're going to want to fix that and account for the orientation. Create a function to handle that. We'll just set up, get an orientation. Okay, and for this, what we're going to use is a combination of get socket location nodes. Okay, so what we're going to do is we're going to take our mesh, just drag it into the graph, and we're going to use, let's see, get socket location. Copy and paste this because we're going to compare two of these here. Okay. So the first one that we're going to use is actually going to be our neck. So neck underscore 1 is the bone that we're looking at. You can also get the bone names inside the content browser under the skeleton meshes. So here's all of our bone names that we're getting. So we're getting the location of neck underscore 1. We're also getting the location of our pelvis. And what we're going to do is we're going to make a rotation based off of these values, but we're going to leave the Z value alone. So ultimately, we're going to make a rotation from ZX, and you'll see how that works here in a moment. But what we need to, which I'll
add on. It's just better for like.
snapshot. So we can drag off of the return value now.
What was it?
Here. The next thing that we're going to do is actually start to use our pose snapshot. Now, when I spoke to our programmers here about this, about the pose snapshot feature, I wanted to get a little bit more information about the feature. Montage. Okay. And I'll copy and paste this, and we'll change that off the false. We'll set this to down. And in either case, we're going to be setting our get up montage here. Okay, so it's just a way of kind of debugging and seeing what's going on, just to make sure. Okay, so back in our event graph, what we can do is call that function that we just created. So we're going to take our setup get up montage and bring that into the graph. So this is all part of our caching process here. The next thing that we're going to do is actually start to use our pose snapshot. Now, when I spoke to our programmers here about this, about the pose snapshot feature, I wanted to get a little bit more information about the feature and how it works. And I met with Ori, and that conversation lasted like 5 minutes because
It's just that simple.
Really easy to use. There's a node inside the blueprint that we can use to save the pose snapshot, and then inside of our animation blueprint, we can call that pose snapshot for blending purposes. So it's really, really easy to use. Just the logic around determining which way you're facing and things like that took a little bit more to set up. So continuing with our cache pose here, what we're going to do is we're going to add a little bit of a delay before we save the pose snapshot. And this is something I need to talk to Ori about this as well. Maybe we can find out after the stream. But we're going to need these delays here in order for this to work properly. So I'm going to add a delay. Okay. And I'm actually going to set it to 0.
The frame delay.
Delay.
So for those of you familiar with blueprints,
Yes.
you probably already know about this little trick. But if you make a delay with a
Set it
duration
to
of
0.
0, it's a frame that it delays. But now you've done a double frame delay, which is a trick that we've talked about in other games like what was it, Robo Recall. There is a double frame delay in it.
Nick Donaldson.
Yeah, Nick Donaldson.
I had this set up, and I'm like, I got it working, and I got them popping up. But it wasn't blending properly. It was just like popping. I needed these 2 delays. I couldn't figure that out for the life of me.
It's really useful. I've actually talked to a couple of different developers here about because I've actually asked them like how can we set up and make a node for frame delay so that I can just do it off of multiple frames. And then we got into a huge discussion about determining the frame rate and making sure that it's actually the frame. And oh my gosh, I really realized like I don't understand frames as well as I thought.
Yeah, same with me. Yeah, because I had set it up without these delays, and I got into the save pose snapshot, and it was all working, but he was still popping, and I couldn't figure out why. I needed these frame delays here. So there we go. So we have those in place. Now we can use our save pose snapshot. For that, we're going to need our mesh and our anim instance. So I can just drag this in. I can drag off of this and say get anim instance. Okay. And this is what's going to allow us to actually call the save pose snapshot. So we can drag off of the return value now, and we can say save pose snapshot. Okay. So this will save the bone transform information for us. We can connect that up. And we need to give it a name. Now we can plug in a variable, or we can just type in one as well. For this particular case, we're just going to type in one. We'll just call it final pose, like so. But it's very important, whatever name you use here, it has to be the same name inside your animation blueprint, obviously, so that you can reference it by name and actually call it. Okay, so that's really all we need to do for save pose snapshot. We saved it at this point, but we need to call it inside of our animation blueprint, which we'll do a little bit later. Okay, so our cache pose setup is pretty much done. It's all of this stuff here is caching the pose. We're going to do that before we actually turn back on physics and be on our merry way with our character here. So with our node selected here, I'm going to add a comment block around it just for being a good blueprinter. We'll just say cache the ragdoll pose and setup orientation and montage, like so. Okay, so now we can continue on down the chain of when we've cached the pose, we've delayed, we're simulating physics, we're saying we're not dead. Now we need to actually play our montage that is being set from our setup get up montage here. So we'll take, let's just take this 2 nodes here, our anim instance and our mesh, just copy those, bring it up here, paste it, and then off the return value we can say montage stop, or excuse me, not montage stop, we're getting ahead of myself here, montage play before we actually stop it. So montage play, we'll connect that up. Okay, and the montage that we want to play is going to be our get up montage. Okay, so we're going to drag that, drop it on top. Okay. So our ragdoll script here is set up. We'll come back to it a little bit later to do a little bit more stuff. Once we start working inside of our animation blueprint, for now it's good. So I'm going to add a comment around that with the C key and just say toggle ragdoll status, something like that. The last thing that we'll do in here before we go into our animation blueprint is set our movement mode. So we're going to create a custom event which will be called with an animation notify, which we'll set up in a moment to allow us to start walking again. Okay, so I'm going to go ahead and add that. And we'll add that below all of this here. So we'll just add a custom event. And we'll just say this is called enable walking, something like that. Okay. And all this is going to do is it's going to take these two nodes here, our character movement component and our setup movement mode. I'm going to copy those, paste those down here, because now we're going to allow us to walk again. So we'll connect this up, and we'll set us back to walking. The other thing that we're going to do as part of our enable walking, once we've allowed us to start walking, is we're going to stop the montage from playing and blend out of it. So we could take our two nodes here again, our mesh and our anim instance. We could just copy that, come down here and paste it. Now we can say montage stop. Say montage stop. So. And this node's pretty handy. You can specify which montage you want to actually stop playing, but if you don't set it, it will just stop all active montages. For now, we'll just leave it like this. I think it's fine. But we are going to set a blend out time here, and we'll set that to something low. We'll just set it to 0.25. We can tune and tweak these values a little bit later if we'd like, so that we blend out of our montage.
And there was someone asking in chat, let's see here, this is going to kind of dip into that, so we can probably cover it right now. Kirili Deli One was asking, the thing that he wants to ask is, how do you make the player rise up slower or faster? And so would that be related to your blend in the montage stop? Or
you could do it there, or it could
itself?
be on the animation itself. You could do it in either case. You'll see some of the examples here, like the animation is purposely slow to begin with, and we're going to get into it a little bit later. And there's also some issues with the animation that I kind of wanted to point out. So we'll talk about that a little bit later as we get to it.
Cool.
So auto commenter on this, we'll hit C and we'll say that this will enable walking again. So we'll let player walk and stop. Active montage, something like that. So our third-person blueprint for now is pretty much done. What we're going to do now is actually set up our montages. We've created them, but there's some things that we need to do in. The other thing that we're going to do is also set up an animation notify here. So name, size here. Okay. So right-click on this and convert this to a peer cast, because we're just going to call an event within it. We're not actually changing anything. What we could do is we could drag off the third. When we revive the mesh, we're going to set both of these to false. And you'll see where these are going to come into effect here in a moment. These for black in this instance, because it's just going to be a little bit easier for me. I'm going to convert that to a peer cast. And I'm going to drag off of this and say player is dead. So it'll set that Boolean variable for us. We could also set it, whoops, you know what, let's delete that and make sure that we compile inside of our animation blueprint first. Did we do that? Yeah, we did. Let's make sure. Set. What did I call it? Player is dead? That should allow me to do that. Of course. Why is it not showing up in there?
Just type in player dead.
It should show up. It's probably because I didn't compile or something.
It's because player is dead is different than set.
Oh,
players.
I was trying to say set player is dead. That's
and it was
right.
throwing it off because it's
there
like you don't have anything that says set also.
Of course, we're all
context sensitivity
yeah.
and filtering. Yay!
Gosh, that was just failure. All right, so player is dead. That's what we're setting there. And then what we also want to do is when we go to revive our mesh, we're going to call revive mesh, which is coming off of this line of script here. So because we've converted it to a peer cast, we can take this same pin here. We could just say revive. There we go. Revive. For this, an error is going to be in the ragdoll pose. So it's just a quick way to fix that. Okay. So back on our anim graph here, to wrap this up kind of, what we're going to do is we're going to take our Boolean variable here of whether or not we're stopped. So I'm going to hold Control and drag that in. I'm going to hold Alt and left click on this to break that up. And that's going to be our true. Okay, so we're stopped. That's true. Let's move that up there. Lens here is what we want is the root to actually be in our character's pelvis. So what's happening is he's kind of coming to his feet, like so. But what we want is the character to kind of get up and shuffle in the same spot. That's probably the problem there. The other thing is that our idle, our default idle, his character's foot is forward a little bit. If we actually look at the idle animation, you can see here, find it, his foot's forward quite a bit. So you're seeing that shift in the feet there. So when you're setting up your animations, you're going to want to have them kind of, I mean, this should probably be all standard stuff, but you're going to want to have them kind of, to get the best blend, be set up for situations like this. You probably don't want to have, 1 foot forward on the idle and then getting up and it's not just facing down. We no longer want to use that one. We're going to, I'm terrible, I can't get myself onto my back. Here we go, let's try this. Yeah.
That's it. There you go. Had to get a good roll.
So he's kind of in that pose and I hit R, gets up in place. Perfect.
Looks great.
Looks good. Now, that's pretty much it. We've got it set up, but we could add some additional things to this to make it look even better. What we're going to do now is go into the physics asset itself and apply some constraints to our actual ragdoll pose. Because what's happening with our ragdoll, he's got so much movement, he can move wherever he wants. So we're going to constrain that a little bit to give it a little bit more weight to our character, as well as kind of, whenever he lands, try to orientate himself so it gets us into a better position to actually blend out of it. So what we'll do is we'll go over to our mannequin folder, character, and the mesh folder. We'll open up the physics asset. And again, if we simulate, and we kind of just hold control, right click, you see he's kind of just all over the place, like so. What we're going to do is use a constraint profile. Let's go ahead and move this over a little bit. Which is up here at the top. Click this drop down. We have this ragdoll profile. Now this is something I created ahead of time. This is what I mentioned kind of in the interest of time. I created this ahead of time, but we'll walk through some of the setup here. So if I switch to that and I simulate, character is going to be a little bit more meaty as he's moving around. A little bit more realistic than just completely, I threw him off. What's cool about the profiles is you can quickly switch between them right here inside of the editor to see the effects of your changes. To add a constraint profile, what you're going to need to do, if you haven't used them before, you might need to come to Window and turn on the Physics Asset window. So you can add that. You get this panel here, Constraint Profiles. You can add a profile, which I've already done and called Ragdoll. To actually use that profile, what you'll need to do is come over to the Profiles section and tell it to use the custom constraint profile that you've created. Once you've done that, you can come to Constraints, and you could select any of the bodies there. And then over in the Details panel, you can add that to your current profile. So you can add whatever ones you want to the profile. Now this particular one didn't add it to it, but I did add like the spine. I added it physics asset. So I'm going to open this there. That is up from his belly, and versus when our character is
velocity or damage input or something.
And we'll just call it so we can go decide to get up. So I'm going to our get socket. Okay, so we're going to plug that in like so. Okay. The next thing that we need to do is determine which animation montage we're going to be using. This is going to be pretty quick and easy. It's going to be based on whether or not we're facing up or down. We're going to our animation montages that we create. I'll copy and paste this pose snapshot, and this is something I need and I'm here. The next thing that we're going to do is actually start to use our pose snapshot. Now, when I spoke to our programmers here about this, about the pose snapshot feature, I wanted to get a little bit more information about the feature and how it works. And I met with Ori, and that conversation lasted like 5 minutes because it's just that.
That's simple.
Really easy to use. Come over to the hierarchy panel here, and we can show all bones or just bones with bodies. We're going to come to the root, and we're going to right-click, and we're going to do that before we actually turn back on physics and be on our merry way with our call the save pose snapshot. So we can drag off of the return value now, and we can say save pose snapshot. Okay. So this will save the bone transform information for us. And connect that. Branch. All that function that we just created. Okay.
Turning the frame.
And popping up.
With blueprints.
We can use to snapshot. So we're gonna just left it. When we're facing montage over here, we're going to do the opposite. A combination out if we do anything else. Let's go ahead and set this to caching our pose. So we say cache pose. Okay. Let's move this over a little bit. And before we start turning physics back on and doing all of that, after we do our cache pose, I'm going to give it a little bit of a delay before we turn physics back on, just so it doesn't execute this all sequentially. That we're going to give it a little bit of a delay here. And we can leave the default value, just like that. Give it a little bit of a delay.